In this lesson, we want to review solving absolute value equations. So before we jump in and start looking at problems where we're solving absolute value equations, we want to make sure that we have a good understanding of the concept of absolute value. So this is something we reviewed at the beginning of the course. So if I said I want the absolute value of the number 7, what am I asking for? Well, the absolute value of a number is the distance from the number to 0 on the number line. So if I want the absolute value of 7, this is equal to 7 because if I started at 7 on the number line and I counted how many units I'd have to go to get to 0, we all know it would be 7, right? Start here, you go 1, 2, 3, 4, 5, 6, and then lastly 7 units to get to 0. Similarly, if I wanted the absolute value of -7, it's also 7 because if I start at -7 and I want to get to 0, I got to go 7 units to the right. So 1, 2, 3, 4, 5, 6, and then finally 7. So these two numbers, 7 and -7, are known as opposites, okay? They have the same absolute value, in each case it's 7, but they lie on opposite sides of the number line. So one's going to be negative and one's going to be positive, right? So you have something like -2 and +2, or -2/3 and +2/3, or -2 million and +2 million, right? So on and so forth. When we take the concept of absolute value and we start working with variables, you really have to think a little bit. So if I had something like the absolute value of x equals 5, what could I plug in for x there and get a true statement? So the absolute value of x is equal to 5. So in other words, I am asking for a value that when plugged in here, I would take the absolute value of it, meaning I want to find the distance between that number and 0 on the number line, and it should be equal to 5. Well, what numbers have an absolute value of 5? Well, it's only going to be 5 and -5, right? So 5 and -5. Okay, so that's what I can plug in for x. If I plug in a 5 there and I evaluate, I get 5 equals 5. That's true. But again, that's not the only solution because -5, the opposite of 5, also has an absolute value of 5. So if I plugged in a -5 for x, you would get 5 equals 5 as well, which is also a true statement. So what ends up happening is we're going to say that our solution for this equation is going to be what? It's going to be that x could be equal to 5. And then we have that keyword or that we talked about in the last lesson with compound inequalities. So x equals 5 or x equals -5. Again, the or just tells me that either works. If I plug in a 5 here, take the absolute value, I get 5. 5 equals 5, that's true. If I plug in a -5, absolute value of -5 is also 5. 5 equals 5, that's also true. So either one works. That's why we use the or keyword. Now, in most cases, we're not going to get something as simple as the absolute value of x equals some number, okay? We're going to have some absolute value of an expression equal to some number, or later on we'll see things get more complicated than that. But essentially, if you have an equation in this format, you have the absolute value operation isolated on one side with an algebraic expression inside of the absolute value bars, and it's equal to some non-negative number like k, then we can go ahead and set up a compound equation with or. We could say that this guy right here, the ax plus b, could be equal to k, or ax plus b could be equal to the negative of k, all right? Now, it's hard to understand this when you look at it in this generic formula, but I want you just to jot this down in your notes anyway. And let's look at the first example, and we're going to kind of relate back to this. So we have the absolute value of x minus 3 is equal to 4. So you see that you have the absolute value operation isolated on one side. You have some non-negative number on the other. Okay, so we're good to go there. So essentially what my formula told me to do was to take this expression here, so x minus 3, and set it equal to this number. So equal to k. Remember, in this case, k is just 4. So equal to 4. Then or, you take your expression again, so x minus 3 could be equal to -4. Okay, remember you said negative k, now it's just -4. Now, why does this thought process work? Well, think about it. If I find a value for x that when I plug it in here and I subtract away 3, it's going to give me 4. Basically, I'm going to be evaluating the absolute value of 4, and that is 4. So I'm good to go there. Alternatively, if I find a value for x, then when I subtract away 3, I get -4. Well, I'm going to be evaluating the absolute value of -4, which is also +4. So that's what I'm looking for. I'm looking to get a result inside of the absolute value bars here of either 4 or -4. Doesn't matter which one it is, because in each case, I will get a value of 4. So let's go ahead and solve this really quickly. On this one, I would just add 3 to each side of the equation. I'm going to get that x is equal to 7. For this one, I'm going to add 3 to each side of the equation, and I'm going to get that x is equal to -1. So let's check these. It's very easy to do. So I'm going to plug in a 7 for x here. So I would have the absolute value of 7 minus 3 is equal to 4. So 7 minus 3 is 4. So I would have the absolute value of 4 equals 4. And of course, that's true. 4 does equal 4. So that's a big check. Okay, so that works. Now, let's check the other scenario. We have x equals -1. So if I plug in a -1 for x right there, so -1 minus 3, we're taking the absolute value of that, this should be equal to 4. -1 minus 3 is -4. So you'd have the absolute value of -4 is equal to 4, and we know that's true, right? The absolute value of -4 is 4, so you get, again, 4 equals 4. So this one's a big check too. So you can see how that ends up working, right? You take this expression right here, this guy, and you set it equal to this number, and then the negative of that number. You solve those two equations, you kind of put it together with that keyword or, and then you're going to have your solution. So there's a few different ways to notate the solution. You can kind of remove these check marks. You don't need them anymore. You can just put an or there between them. So x equals 7 or x equals -1. That's fine. You can use the solution set notation and say you have -1 and 7 as the elements, or basically solutions that work for your equation. And then lastly, you could also do this. You could say x equals 7, comma, -1, right? Lots of different ways to notate this, but just make sure that you're indicating that each one is a solution to your equation. All right, let's take a look at another one. So we have the absolute value of 5x minus 4 is equal to 6. So again, we're following the same thought process. We're going to take this expression inside the absolute value bars. So 5x minus 4, we're going to set it equal to 6. Then we're going to have or, we're going to have 5x minus 4 is equal to the negative of 6. Okay. So what I want to do, I want to solve each one of these. So I want to add 4 to each side of the equation here. That's going to cancel. I'll have 5x is equal to 10. Divide both sides by 5. And I'll get that x is equal to 2. Over here, I just want to add 4 to each side. That's going to cancel. I'll have 5x is equal to, you'll have -2. Divide both sides by 5. And you'll have that x is equal to -2/5. All right, so let's erase these. So I'm going to go ahead and say that x is equal to 2 or x is equal to -2/5, like that. Again, you can write it that way. You can use the solution set notation. A lot of books do that. Or you can also just say that x equals 2, comma, -2/5, right? Each is a solution. Now, again, if you want to check this, you could plug a 2 in for x. You could also plug a -2/5 in for x, and you would see that the left and the right side are equal. So let's go ahead and check it. So the absolute value of 5 times 2, and then minus 4 is equal to 6. So 5 times 2 is 10. 10 minus 4 is 6. The absolute value of 6 equals 6. So 6 equals 6. So yeah, that's true. You can check that one off. Then the other one is -2/5. So -2/5. So 5 times -2/5, the 5s would cancel. You'd have -2 minus 4, which is -6. So you basically have the absolute value of -6, which we know is 6. So 6 equals 6 here. So this one checks out as well. So again, x equals 2 or x equals -2/5. Let's look at one that's a little bit more complicated. It's just more complicated because you don't have the absolute value operation isolated on one side. So we have 5 multiplied by the absolute value of -7x plus 3 equals 58. So your goal, if you get something like this, is to isolate the absolute value operation. So how can we do that? It's very, very easy. You just think about what's being done to that absolute value operation. You have multiplication, right? You're multiplying by 5, and you have addition, 3 is being added to it. So let's go ahead and subtract 3 away from each side to start. We'll get rid of that. We'll have 5 times the absolute value of -7x plus 3, and this equals 58 minus 3 is just 55. Now I can just divide both sides by 5. So I divide both sides by 5, And this would cancel with this. And so I have the absolute value of negative 7x plus 3 is equal to 55 over 5 is 11. So now I have it in the format that I've been looking at. And again, once I have it like this, it's very, very easy. I take my expression, so negative 7x plus 3. I set it equal to 11. And then I say or. I take my expression, so negative 7x plus 3. I set it equal to negative 11. Okay? Just solve each one. Very, very simple. So I'm going to subtract 3 away from each side of the equation. I'm going to get negative 7x is equal to 11 minus 3 is 8. Then I'm going to divide both sides by negative 7. And I'm going to get that x is equal to negative 8/7. Over here, let me subtract 3 away from each side. That cancels. You'll have negative 7x is equal to negative 14. Divide each side by negative 7. And you get that x is equal to positive 2. So let me erase this. So again, x equals 2. So you can leave this as your solution. Again, you could write it in solution set notation. You could put the comma. There's a zillion different things you can do, whatever you're more comfortable with. So let's go ahead and check this real quick. And then all the rest of them, I'll leave that up to you to check them on your own. So I would have 5 multiplied by the absolute value of, I'd have negative 7 times negative 8/7. So we know that this would cancel with this. The negatives would cancel, so I'm basically just going to have an 8 there. So I'd have 8 plus 3, which is just 11. So then plus 3 equals 58. So the absolute value of 11 is 11. So you have 5 times 11 there. That's 55, and then 55 plus 3 is 58. So this one's good to go. Over here, you have the 2 that's going to be plugged in for x. So 5 times the absolute value of. Negative 7 times 2 is negative 14. Negative 14 plus 3 is negative 11. But again, because I'm taking the absolute value there, it just becomes positive 11. So 5 times 11, then plus 3 equals 58. We already know that's true. 5 times 11 is 55. 55 plus 3 is 58. So we're good to go in each case. Again, our solution is x equals negative 8/7 or x equals 2. All right, let's take a look at another one. So suppose we had 4 multiplied by the absolute value of negative 7 minus 10x. Then we had plus 5, and this was equal to 17. Again, my goal here is to isolate the absolute value operation on one side and then to have a number on the other. Okay, so what I want to do, I want to just subtract 5 away from each side of the equation to start. So we know this would cancel. So we'll say we have 4 times the absolute value of, we have negative 7 minus 10x. And then this is equal to 17 minus 5 is going to give me 12. Scroll down and get some room going. All right, so to isolate the absolute value operation, I have 4 that's multiplying it. So all I need to do is divide both sides of the equation by 4. So we know that, again, this would cancel. I'll have the absolute value of negative 7 minus 10x. This will be equal to 12 divided by 4 is 3. So now we have this in the format of our absolute value operation equals some number. So the absolute value operation here is equal to some number. So I can set up my compound equation with or. So I just take the expression inside. In this case, it's negative 7 minus 10x. I'm going to set it equal to 3. Then or, I'm going to take my expression inside, so negative 7 minus 10x. And I'm going to set it equal to the negative of 3, so negative 3. And then I'm just going to solve these two equations here, and I'll have my solution. So on the left, I'm just going to add 7 to each side of the equation. I'll have that negative 10x is equal to 3 plus 7 is just 10. And now we can divide both sides of the equation by negative 10. And of course, this guy's going to cancel. I'll have x is equal to 10 over negative 10 is just negative 1. So that's one solution. Let's get our other solution over here on the right. So again, I'm going to add 7 to each side of the equation. This is going to cancel. I'll have negative 10x is equal to negative 3 plus 7 is going to be 4. So now let me scroll down and get a little bit more room here. If I divide both sides of the equation by negative 10, then this guy right here is going to cancel with this guy, and I'll have x is equal to 4 over negative 10. We know that's negative. They're each divisible by 2. 4 divided by 2 is 2, and 10 divided by 2 is, of course, 5. So I get x equals negative 2/5. So I can write this as x equals negative 1, or, my keyword or, x equals negative 2/5. Again, you can do the solution set notation, or you can just list them with a comma, whatever you want to do. All right, so let's take a look at some special case scenarios that come up when we're solving absolute value equations. So the first one we're going to talk about is the situation where you have no solution. So something like the absolute value of x is equal to -5. This guy would not have a solution. So no solution. Why is that the case? Well, we should know that the absolute value of some real number x is greater than or equal to 0. Because if I plug in a 0 here, I'd get 0. If I plugged in a negative here, I'd get a positive. And if I plugged in a positive, I would get a positive, right? This stems from the definition of absolute value. When you take the absolute value of the number, you want the distance from 0 to the number on the number line. So if it's 0, it's just going to be 0. If it's some negative, again, you'd get a positive. If it was a positive, it would just be a positive. Okay, so you're never going to get a negative result. So this guy would always be no solution. When we go back to our generic formula here, I said earlier that the absolute value of some expression ax plus b, if this is equal to k, k has to be non-negative. So if you have isolated this guy right here, the absolute value operation on one side, and on the other side you have a negative value, you can stop and say there's no solution. What you don't want to do is say there's no solution before you've isolated the absolute value operation on one side. That can lead to problems, okay? So you need to make sure you isolate first. All right, let's take a look at an example. So we have 9 times the absolute value of 5x minus 1, then plus 10 is equal to -44. So the idea here is that we want to isolate the absolute value operation on one side of the equation, and then we want a number on the other. But if that number on the other side happens to be negative, we're not going to have a solution. So don't just look at the negative over here on the right-hand side and assume that this guy is going to be a no solution to start. You've got to isolate the absolute value operation before you can make that determination. So I'm going to start by just subtracting 10 away from each side of the equation, and we'll cancel this. We'll have 9 times the absolute value of 5x minus 1. And this is going to be equal to -44 minus 10 is -54. So at this point, you pretty much know it's going to be no solution. But let's continue. Let's go ahead and divide both sides by 9. And of course, this will cancel. We'll have the absolute value of 5x minus 1 is equal to -54 over positive 9 is -6. So we know at this point there's no solution. Right? There's no solution. We have isolated the absolute value operation on one side, and we have a negative number on the other. So we can just say that there's no solution like this. This is what I always do. I just write no solution. A lot of textbooks, again, will use the symbol for the null or empty set, which looks like this. That's fine, too, if you want to write that. It's basically anything you want to do. So again, I just want to emphasize here why there's no solution. There's no value I can plug in for x there. Multiply by 5, and then subtract away 1, and then take the absolute value of it and get -6. Doesn't matter what this value is. Once I take the absolute value, it's either going to be 0 or positive. Okay, so it can never, ever, ever be -6. So that's why there's no solution. Now, let me show you one thing real quick. Just want to make sure we're crystal clear on this before we move on. If, for example, I change this problem, and I'm not going to go all the way through, but if I change this problem to a negative out in front, you will have a solution. Okay, let's work through that real fast. I'm not going to go all the way through, but I'll just show you. If I subtract 10 away from each side here, that would cancel. I'll have -9 times the absolute value of 5x minus 1 is equal to -44 minus 10 is -54. Now if I divide both sides by -9, what's going to happen? Let's scroll down and get some room. Well, we see that this guy right here cancels with this guy. So I've isolated the absolute value of 5x minus 1. But now -54 over -9 is +6. So I would have a solution here. I would have to set 5x minus 1 equal to 6, and then 5x minus 1 equal to -6. So I would have that compound equation with OR, and I would get 2 solutions there. I'm not going to go through that process, but I'm just making sure that you understand that just because I start with a negative on the right-hand side doesn't mean that I have no solution. You've got to get to the point where you've isolated the absolute value operation on one side and a number on the other. If the number is 0, then you're just going to have one solution, which we'll talk about in a minute. If it's positive, you're going to have 2 solutions. And if it's negative, you're going to have no solution. All right, let's think about another scenario we're going to come across. So suppose the absolute value of x was equal to just 0. Well, in this case, you're not going to have to set up a compound equation with or. You're just going to have one equation. The absolute value of x equals 0 only if x is equal to 0. Okay, that's the only possible solution there because the only number that has an absolute value of 0 is just 0. 0 doesn't have an opposite. If this was the absolute value of x is equal to 2, again, x could be 2 or it could be negative 2 because each have an absolute value of 2. But when you get 0 there, you only have one unique number that has an absolute value of 0, and that's just 0. So let's look at this equation here. So we have 4 times the absolute value of 2x minus 14, then plus 5 is equal to 5. So again, our goal is always to isolate the absolute value operation. And when I subtract 5 away from each side, you're going to immediately see you have a problem. You get 4 times the absolute value of 2x minus 14, and this is equal to 0. So if I divide both sides by 4, we know 0 divided by 4 is just 0. So I'm going to end up with the absolute value of 2x minus 14 is equal to 0. So this is a special case scenario, okay? You do have a solution here, but you only have one, okay? You're not going to get two. So you need to pay close attention to what to do here. So all we need to do is say that 2x minus 14 is just equal to 0. We're just going to solve that equation. So I'm going to add 14 to each side. And of course, this is going to cancel. We'll have 2x is equal to 14. Then we're going to divide both sides by 2. And I'm going to get that x is just equal to 7. So just one solution here, x equals 7. So lastly, let's think about what happens when we have two absolute value operations set equal to each other. So something like the absolute value of ax plus b is equal to the absolute value of cx plus d. So the way we think about this is two numbers or expressions can only have the same absolute value if they're equal to each other or if they're opposites of each other. So we would say ax plus b is equal to cx plus d. So in the first scenario, just remove the absolute value bars and set the two expressions that were inside of the absolute value bars just equal to each other. Then or, next you're going to remove the absolute value bars and you're going to put parentheses around one of the expressions and basically negate it, right? So you're going to put a negative sign in front of it or make it into its opposite. You can even put this as a -1 out in front just to make it crystal clear what you're doing. And it would be just as valid if I said or, and I put a negative out in front of ax plus b and said this is equal to cx plus d. Just don't make them both negative. Only make one of them negative because you need them to be opposites. So let's look at our example. We have the absolute value of 4x minus 5 is equal to the absolute value of 9x plus 7. So again, I'm going to drop the absolute value bars. So I'm just going to say this is 4x minus 5 is equal to 9x plus 7. So I'm going to solve that. Then you have or. I'm going to drop the absolute value bars. So I'm going to have 4x minus 5 is equal to, you have 9x plus 7. So I'm going to choose one of these expressions. It doesn't matter which one you want. Wrap it in parentheses and put a negative out in front, okay? You could do this one, or again, doesn't matter. You can do this one. You will get the absolute same answer. Just for the sake of what we did earlier, I'm going to go ahead and just wrap this around here and just be done with it, okay? So for the first one, I'm just going to solve this. I'm going to write this down here. So we have 4x, again, 4x minus 5 is equal to 9x plus 7. Let me scroll down and I'll come back up. So to solve this is very, very easy. We just add 5 to each side of the equation. That cancels. 4x is equal to 9x plus 12. We subtract 9x away from each side of the equation. And this is going to cancel. So what I'm going to have is 4x minus 9x is negative 5x. And this is equal to 12. We can go ahead and just divide each side of the equation by negative 5. And we're going to find that x is equal to negative 12 fifths. So let's erase all of this. We're going to keep that x equals negative 12 fifths. So I don't need this equation anymore. I'm just going to put x equals negative 12 fifths. And then I'm going to have my or here. I'm going to do it vertically. And then I'll have x equals something here. And we'll get that from this. Okay. So here I'm going to distribute my negative to each term. Again, if you have trouble with that, put a -1 there and then distribute. Okay, that's the easiest way to remember. So 4x minus 5 is equal to -1 times 9x is negative 9x. And then -1 times 7 is minus 7. Now, what I want to do is add 5 to each side of the equation and add 9x to each side of the equation. So this is going to cancel. and this is going to cancel. 4x plus 9x is 13x. This is equal to negative 7 plus 5, which is negative 2. If we divide each side by 13, we're going to get that x is equal to negative 2/13. So x equals negative 2/13.